Okay, we'll talk about some residential and MDU applications, specifically with DC voltage lighting and power distribution. To kind of get a core basis, though, broadly speaking, there are several different classifications of equipment. There, with DC voltage, we specifically have Class 2 and Class 4. So Class 2 would be more broadly known as Power over Ethernet, or PoE. There's a broader spectrum to that, but the foundation is it's basically everything that's under 60 volts DC and at under 100 to 120 watts. Within that, it's low power devices, relatively shorter distances. You broadly speak it within about 200 to 300 feet is about as far as you want to go. The other side of that is Class 4 power. Class 4 power is also DC voltage. It's up to 450 volts, but it's pulsed. And because it's pulsed hundreds of times a second, it has multiple benefits. One primarily being it's safe. Because it can shut off almost instantly, it's a very safe means to transmit power. Also because that pulsing, it doesn't develop a magnetic field or have any EMI. So what happens is you can then use that power in the same raceway as your low voltage. What happens is usually you need to separate your electrical and your low voltage wiring because of the electrical interference. But when we use Class 4 power, it can be in the same raceway. So think about a light, to say on the opposite side of a building property. You'd have to trench the parking lot to get out to it to go say put a security camera on it. Well, we can use that same conduit that's already there to pull back, and then we can run this down that conduit to provide power for the light, the security cameras, and the telecommunications all in one raceway. So Class 2 power, Class 4 power. In the residential setting, I am going to be exclusively talking about Class 2 circuits. When we deal with commercial, I'll bring in Class 4. So if I was to do a house right now, any size house, what would I want to do? There are multiple different brands available. So there are all these, called a nascent industry, where there's some well-established guys that are around for a decade, but they haven't seen significant adoption. What I really like about LumenCache is the ability for us to have all of our DC loads, basically think everything above the knee, your fans, your sensors, your lighting. We can also do this for power distribution for our IT. So what we do is we have simple takeoff tools that LumenCache has developed, allows us to put in a really simple bit alternate. And as part of that, essentially what we're doing is we're doing a panel that's adjacent to the electrical panel. So we're still going to have a regular circuit breaker panel like normal, but then we're going to have a low voltage DC power distribution panel adjacent to it. And what I'd like you to think of this here is you might have a router, you might have your access point, your cable modem. With that, what we've got is DC power going straight to it. And if I did just this, no battery at all, just this, it's probably going to have a price premium of about maybe 10 to 20% depending on the installation. But the benefit here is now everything's come back as DC voltage. Now all of these are digitally enabled devices. I can control my lights. I can provide USB power throughout the home. I can give a simplified app, and it can be anybody's app. It doesn't have to be one specific. So when you look at this, I have the ability to now do things with all of my devices as I evolve and I grow into that facility. Now, if I take that one step further and I add in a battery, now things start to get interesting. So this battery is relatively low cost. So if you look at a price for a Powerwall 3, you look at those as somewhere right around a $8,000 purchase price, but to install them, you're typically about $15,000 all in for a typical house. One Powerwall 3 all-in installation permits labor, materials. By comparison, a very basic 48 volt battery, just in the regular industry, it goes between about $1,000 and $1,200 for a 48 volt 100 amp hour battery. What that means is it can support 5,000 watts of power for 1 hour. So if you look at size of the house I live in is about 4,200 square feet. If I took all of my lighting loads, and it's Christmas time right now, so I even got Christmas lights. All of those loads are already LED, and it's about 2,000 watts for our house with the Christmas lights on. If I took my IT loads as well, like my access points, my network switch, my Google Fiber modem, I might have maybe 2,500 watts of total load with everything on. one battery for about $1,000 plugged into this guy could power my house for 2 hours. A regular house, it might be the entire day, right? You have a regular, just a couple thousand square foot home. We're abnormal by comparison. So looking at it, it's not that it's $1,000 upgrade. You're going to have some extra parts here, so you're still going to have a few $1,000. But instead of paying $15,000 for a solution that backs up the entire home or part of the home, this would allow you to have all of your lights stay on, all of your IT and your security stay on for a few $1,000s of components, as long as you've made the choice to install a DC power distribution system in that home. Now take that a step further. Let's say we do have a Tesla power share. So this is a concept in another video where we talk about every Cybertruck owner has the ability to have their vehicle be a battery for the house. The challenge is that when you have that vehicle plugged in, there's a blip of power as it transfers back and forth. So normally if it's just plugged in and it's just doing its regular thing, it's fine. But when you have a utility outage from Rocky Mountain Power, it takes between half a second and about 2 seconds for the power system to recognize, hey, power's not there, disconnect the house from the utility, and then allow that Cybertruck to start providing power to the house. Well, all of your IT systems went off within the first 20 milliseconds. Blink of an eye. If we have that low voltage DC power distribution for the lights and the IT, now what happens when this goes back and forth with its power share is all your lights stayed on, all of your core IT stayed on, your access point, your router, your security cameras, right? Also, let's say you're not a Cybertruck owner, you're a Powerwall owner, or you have a solar array with a battery energy storage system. When we do that, we can also have the same functionality, because that still happens. You have that battery energy storage with the Powerwall 3, the lights are still going to go off when it transfers back and forth, unless you put them on a battery. So our premise there is that, yes, we're actively doing this work here. What we'd really want to solve is providing power distribution within those residential and MDU properties. So overall, we're very excited about this. We are a master distributor for Lumen Cache, and they have some new products on the horizon. With this, what we need are a couple of things. One is we need to have a conversation with developers about this technology. This Lumen Cache has been around for a decade now. Also, we want to be able to have that ability to get that larger project to get some initial inventory. This product definitely has a little bit of a lead time right now. And so what we want to be able to do is find that, say, 400 unit townhome property, put down our down payment and buy this and procure it so that we can get ahead of some of that supply and demand getting into next year. It also could just be a relatively smaller 1 or 2 jobs, but the challenge here is we do not have this in stock right this moment. It will be Q1 before we have product we can use that's exactly this from Lumen Cache. So we're looking for other alternatives in the meantime. But this is a very, very good solution for this coming year. Appreciate it. Step to the next topic.